Good morning, grade 7s. I hope you've had a wonderful weekend and are ready for a new week of e-learning. Hopefully this will be one of our last weeks of e-learning. Today we are doing lesson 12 part 1 and we are going through topic 10, which is surface area and volume of 3D objects. This can be found on page 126 in your textbooks. Today we're focusing on the subsection solids. So as you know, all 3D objects or solids have 3 dimensions. We work with length, with width, which is the same as saying breadth, and then height. So those are the 3 main dimensions that any 3D object has. Then if you look at the diagram of this 3D object or the solid, we deal with 3 aspects or components of a 3D object. This is an edge, a face, and a vertex. Now if you look in the purple block on the side, a face is a flat surface on a 3D object. So if you're looking at a 3D object, it's basically any flat surface we refer to as a face. An edge is the line where 2 faces meet. So if we're talking about a cube, for example, a cube, the side of the cube would be the edge. And then the last one, the vertex. Remember, one vertex, many vertices. This is the point where 3 or more faces meet. Okay, so in other words, it's the corners of our 3D objects. Now it says, when looking at prisms, we can see that there are vertices which do not share a common face. These are called diagonally opposite vertices. Now I'm going to highlight that term, because it is very important. You do need to be able to give me diagonally opposite vertices. And these are basically vertices which are found on opposite corners of a prism. Look at the below diagram to see some examples. So what I've done is, I've got the same shape over here. I've written the vertex or vertices on each corner so you can see a practical version. Alright, so this is my 3D object. It's a rectangular prism. Now the question will say, for example, they'll give you the vertex A, and they will say you need to name a diagonally opposite vertex to A. So what that basically means, if you're looking at your shape, the vertex over here, which they give to us, which is A, they say a diagonally opposite vertex is one that do not share a common face. So you can see A over here, it touches this face, it touches this side face, and it touches this side face. So we need to find a vertex that does not share those faces. So the easiest way of thinking about it is, if you had your shape and you stuck a pen or pencil through the corner of the shape right through to the other side, what corner would it come out? And in this case, the opposite corners, obviously if this one's at the top, this one must be on the bottom. And if this one's in the front left corner, this one must be in the back right corner. So it's basically your opposite vertices. So the diagonally opposite vertex of A would then be E. So if you look at your diagram over here, it's exactly the same labels. So you can see there's A, it's in the front. If we stuck something through the shape to the back of the shape, it would get to vertex E. So it says there vertex A is diagonally opposite to vertex E. Now we can do the same with any of them. So if we took, for example, the vertex G, so the one that would be at the back, and we stuck something through, it would come back to the front of the shape. So it would go right through the shape to the front, and that's to vertex D. So whenever we're talking about a diagonally opposite vertex, it's basically the opposite corners. So it will be the top one and the bottom one at the back. This top one, that bottom one. Alright, this bottom one, that top one. So you just need to play around with the shape. It's a good idea maybe to find a cube shape at home, like I did over here with this box, and you can write the vertexes on and you can play around to find your vertically opposite vertices, diagonally opposite vertices. Alright, then just something to remember, When I talk about lines being perpendicular or faces being perpendicular to each other, that means they meet at a right angle. So if we look at our shape here, this face and this face, they form a perfect 90-degree angle, so those two faces are perpendicular. Alright, now just a quick recap of some grade 4, 5 and 6 work. We've got to name a few 3D objects and they fall into a few categories. So the first category we talk about is polyhedra. So it's one polyhedron, many polyhedra. Okay, now these are solids that are only made up of flat faces. So all the faces have to be flat. Now our first grouping under that category is a prism. Now prism is a 3D object with two parallel, in other words they're same distance apart, and identical faces that are polygons. In other words, if you look at your prism, the opposite faces must be parallel, so the same distance apart, and they must be identical in size. The other faces are all rectangles and they're all at right angles to the end faces. These faces are called lateral faces. So basically with a prism, we've got our end faces. All the other faces going around are called lateral faces. Okay, here's some examples of prisms that you need to know. We've got our cube, that is a square face going all the way around. We've got our rectangular prism, otherwise known as our cuboid, triangular prism, pentagonal prism, hexagonal prism, and our octagonal prism. Now these prisms are named according to their end faces. So if it's a triangular prism, we know the end faces will be triangles. If it's a pentagonal prism, we know the end faces are pentagons. Right, then our next polyhedron shape or category of shape is pyramids. Now a pyramid is a 3D object with a polygon base. All other faces are triangles that meet up at a common point called the apex. These faces are called lateral faces. Now unfortunately I don't have a practical example, but we know that our pyramid has a base. Okay, it can be a square, rectangle, triangle, any shape basically. That base is what it stands on. Then all the other faces come up and they meet at a point on the top. That point is called an apex, and all of these faces leading up to that point are called lateral faces. So here we've got a triangular based pyramid, otherwise known as a tetrahedron. Then we have a rectangular or a square based pyramid, obviously again named by the shape of its base. So those are the polyhedra groupings. Now we go to solids with curved faces. Now they don't have a special name, they're just known as other shapes. So we have our sphere, that's like a tennis ball or a soccer ball. Then we have a cone, so if you think of the cones that we use on the road, or an ice cream cone. And then we have a cylinder, that's like a pipe. So the two end faces are flat, and then obviously the face going around is curved. So these are the types of solids or 3D objects that you need to know. In the next lesson, we'll continue with this section.